Hey, everybody, and welcome back to another episode of Adventures in Machine Learning. This week on our panel, we have Francois Bertrand.
Hello.
We also have Ben Wilson.
Hello.
I'm Charles Max Wood from devchat.tv, and this week we have a special guest, and that's Ville, do I dare try and say your last name? Tuulos?
That's right. Sounds perfect. Well, thanks for having me.
Yeah, absolutely.
Did you work your tail off to get that senior developer gig just to realize that senior dev doesn't actually mean dream job? I've been there too. My first senior developer job was at a place where all of our triumphs were the bosses and all the failures were ours. The second one was a great place to continue to learn and grow, only for it to go under due to poor management. And now I get job offers from great places to work all the time. Not only that, but the last job interview I actually sat in was a discussion about how much my podcast had helped the people interviewing me. If you're looking for a way to get into your dream job, then join our Dev Heroes Accelerator. Not only will we help you get the kind of exposure that makes you attractive to your dream employer, but you'll be able to ask them for top dollar as well. Check it out at devheroesaccelerator.com.
Now, we're going to be talking a bit about data science infrastructure. And yeah, I think we got access to your book and kind of got to dive into it a little bit, which is really fascinating. But you're probably the most qualified person to give us an introduction. So when we're talking about data science infrastructure, what generally are we talking about?
Yeah, well, that's definitely a good question. And actually, that's part of the motivation why I wanted to write the book in the first place, because many people, many companies these days are exactly asking the same question and wondering that, okay, so my general feeling is that there are many companies who are trying to figure out how to use machine learning and how to use data science to make their businesses more effective. And this was definitely the situation at Netflix, where I used to work leading the machine learning platform team for the past 3 years or so. And Netflix is, of course, quite an interesting company, and many people know that they have invested a lot in recommendations. So all the TV shows and movies you see, when you go to netflix.com, but not many people know that there are actually many other machine learning applications that Netflix wants to use and wants to develop kind of behind the scenes. And now Netflix was asking exactly the same question about 4 years ago. That, okay, so if we want to have all these applications of natural language processing, computer vision, classical statistics, what kind of a data science infrastructure do we actually need? And what does it even mean exactly? And the basic idea there is that, okay, so there are ideas where we want to apply machine learning and data science. On the other hand, we have people who are supposed to work these things. And there's kind of the feeling that if we give these people nothing, if we have the domain experts, data scientists, and maybe they have to just write everything from scratch, well, obviously that's not going to be optimal. I mean, they're going to spend too much time on engineering, it's just building a very, very basic supporting infrastructure for doing things that every single machine learning and data science project needs to do. And that's why when I started at Netflix and when my team started thinking that, okay, how can we actually help these people? How can we make them productive? We started thinking that what are the most fundamental components that every data science machine learning project needs? And it starts from the very basics that, well, I mean, everybody needs data. I guess that's given. Everybody needs to do some compute, and everybody needs to, at the end of the day, orchestrate these complex applications, complex workflows in some manner. And that's my view. And I know that there are different people with different views, that's my view of data science infrastructure, that starting from the bottom up, what are the most fundamental and foundational things that we have to provide for data scientists to make them productive. And then how we think about using existing pieces of infrastructure. I don't think that ML is that special that you would have to reinvent everything from scratch, but I mean, put them together in a very easily usable, productivity boosting package. So, and that's really what the book is about, and what I was doing with my team at Netflix as well.
I mean, I'm curious to hear a little bit about where you went from defining those core competencies that are common to pretty much every ML application or project that you do. And once you define those, what was the process like for our viewers that are out there, our listeners, who are maybe thinking about doing this? Hey, we want to build a framework at our company that is specialized to our business. What was that process like leading up to the time between defining those base characteristics all the way to you open sourcing Metaflow for the first time?
Yeah. Good question. Well, to answer very directly, that if there are people out there, in the listeners who are interested, I mean, definitely take a look at the book. I mean, kind of the idea with the book is to kind of walk through that process in a very bottom up manner, so you can do it at home as well. Now, what we did at Netflix is that we knew, and this is actually like maybe partly like due to the Netflix culture as well. They have this concept of giving a lot of autonomy to all employees. So we couldn't just go and say that, okay, we are going to build this thing and like everybody's forced to use this. I mean, there's even no CTO at the company who could say that like everybody is kind of that there's the mandate that everybody must do things this way. So we knew that like whatever we are going to build, it has to be something that it appeals to these practicing data scientists, machine learning engineers, so that they would actually like choose to use these things voluntarily. And hence we knew that like we have to address the pain points that they have and things that they don't want to do. And then on the other hand, like allow them to do things and allow them to have a lot of freedom with the things that like they actually feel that they want to decide by themselves. So we actually like had the pleasure of working with many people, and like we asked a lot of questions. And of course, given that I had been doing this already before at other companies, so it gave me some perspective. So we didn't only like do the first things everybody was asking for, but quite soon, like we started realizing that again, I mean, there are these very, very like basic questions that, okay, so people were asking that, let's say I'm prototyping something in my notebook, and then let's say I have a big pandas data frame, and then the pandas data frame runs out of memory. So I need a bigger instance. I need like access to more resources, and how do I make that happen? And then the first step is that, okay, how do we help people scaling up these prototypes, even without going to production? And then that's the question of the compute layer, and like how can we actually farm out these machine learning tasks or functions to the cloud? So very basic question. Another one like that people ask often is that how do I access data? I mean, obviously Netflix has a big data warehouse. Many other companies have data warehouses, databases. So very basic questions that how do I access data from these systems? And then how am I supposed to manipulate the data in my pipelines? So another like a very basic question that we wanted to answer. And then lastly, there's always the question, a big one, that how do I deploy these models? Let's say I managed to deploy something, I managed to develop something, I managed to that scale. How do I then like deploy it to production? And that's of course like really an interesting one. And also we realized that what is meant by production is really a spectrum. There are many different kinds of production. And then like how can we help people who are not necessarily distributed systems engineers, who are not necessarily SREs, and like people who kind of build highly available systems as a day job to kind of actually build workflows that like we can dare to use in production, even for business critical applications. So I guess a long story short, it was definitely an iterative process. And important thing for us is that like we didn't overfit. We didn't look only at a single type of use cases, not only at the deep learning use cases, not only at the like a classical statistics use cases, but looking at the wide spectrum of different things and like looking for commonalities and then package them then thoughtfully in a single frameworks.
Awesome. I mean, I would take that as a recommendation for people just doing ML project work is to follow that same process. A lot of people in the ML space, like data scientists who are looking at how ML engineers, infrastructure engineers for ML do things. They're like, oh, they're software developers. It's like, no, maybe you should follow how they build projects because it makes for more successful ML as well, following how you built that and got it to meet all of the needs. And I was really intrigued by what you said about the spectrum of production releases. Mm-hmm. And it's something that I talk to customers a lot about. A lot of people are like, oh, I need to get it to serving. I need to get it to production. So what that means to me is creating a REST API for something that only requires a batch inference. Mm-hmm. Or somebody saying, well, we have to deploy on K8s and we need this massive scalability. It's like, well, you have 4 people hitting the API a day. Yeah. So no, you don't need that. So what sorts of things have you learned over your years of doing this about that spectrum that maybe the listeners can say, oh, this is what I can learn from this book?
Yeah, well, I would have to say the rule of thumb is that I felt oftentimes that I'm a totally overpaid person, like just saying that you can do it simpler. That like exactly to your point about not everybody needing kind of the massive scale, and not everybody needing, let's say, I mean, like not even all applications need the same level of SLA and high availability, and like then you can like choose your approach accordingly. And as we know in engineering, everything comes with the trade-off. And of course, if it was so that like, well, I mean, we can do everything at Google scale or whatever, and it doesn't cost anything, sure, I mean, why not? But I mean, oftentimes then the cost comes on the, let's say, on the iteration side. Anyways, long story short, like my experience is that, machine learning comes in all shapes and sizes. There isn't like one template that this is what all machine learning, this is what all data science looks like. I mean, it's the same thing as with software engineering. I mean, if you said that, okay, this is the way how software engineering artifacts, this is how software needs to be deployed to production. I mean, that's meaningless. I mean, what does it mean? It's one thing to build embedded software. It's another thing to build like a distributed databases. It's yet another thing to build like web applications. It's yet another thing to build front-end applications. So, and everybody understands that when you deploy software, well, I mean, it really depends on the use case. And I don't think that's very controversial. Exactly in the same way, of course, some ML applications need to be deployed as a REST API. Some ML applications get deployed at the edge on, like, let's say, even on mobile devices. Other ML applications are batch processes that run once a night. And another ML applications, actually, it's just like a write to a like Excel spreadsheet. So yeah, I mean, it really, it's a wide variety. And like, exactly to your point that I mean, definitely, I mean, it's not always a REST API. Interestingly enough, anytime like you have to do a massive number of batch predictions, let's say, I mean, it's probably like way more efficient of not having a REST API and just like a crunch through the data as fast as you can by other means. So, and I think it is actually like actively counterproductive to think that like there's a one linear way of deploying everything and there's a one deployment target. Now, the thing is, of course, that this is company dependent. And if all your company does is that like, well, there's a one microservice you need to deploy. Let's say there's a recommendation systems and it runs as a microservice. Well, I mean, maybe that is the one deployment target. But I think at least you should keep an open mind that next time your marketing department comes and says that, okay, we need to optimize our marketing budgets. Well, I mean, it might not be microservice that time. I mean, maybe it is something different. So, and then you can choose accordingly. And I think that like whatever approach, whatever framework you are using, I mean, it supports like all these different modalities.
I mean, I have a question on Metaflow, which the book is about, because it does feel like the holy grail of that kind of abstraction layer over everything from data warehousing to feature engineering and model development. It's trying to accomplish, so you can plug in kind of whatever your use case is at every layer for warehousing or model versioning and all of that. And it really feels like, potentially extremely powerful. There's so much to go over, but there has to be some places that were more challenging than others to kind of try to abstract away, like you said, every possible case for edge or cloud deployment and parallel processing. And I mean, what do you feel were the most successful or easiest places where Metaflow really succeeds at, where there's still challenges when you're approaching something that potentially could be, the Uber solution where everything's abstracted away and you have one kind of workflow for every project because you've plugged in everything you needed?
Mm-hmm. Yeah, well, I mean, like first, just to clarify, I mean, the idea is not so that Metaflow would necessarily solve all these problems for you. I mean, what Metaflow does is that it solves some things that are like very common to all projects. Again, I mean, compute, data orchestration, versioning, so forth. Now, the idea is that you definitely have to do some legwork then to integrate to your like specific systems at your company. So again, I mean, like drawing the parallel to software engineering. I mean, if there was a software engineering framework that said that, well, I mean, we are going to solve every single problem and like do everything for you. I mean, of course, nobody would believe, and that wouldn't make any sense. But I do think what makes sense is that like you can have a solid foundation, you can have a good starting point, and then on top of that, you can definitely like build by yourself pure like custom solutions. So actually, like just to give you an example, even at Netflix, what happened is that we provided Metaflow as a common base layer, and then different teams, different parts of the organization focusing on different problem domains, they built their own like a thin layer of abstraction on top of Metaflow to address their own specific needs. And like a good example, I'm actually like going back to your question that like where we were successful and like maybe where like we were less so. I think overall, I mean, like with these basic questions, especially with compute, I think that like that's actually really a pleasant experience today. Orchestration, like I think we're doing a decent job. Data is always a hard problem. And actually, like especially in the context of machine learning, it's an interesting thing that like over the years, like we thought a lot about what we should do with feature engineering and feature stores. And it's such a gnarly amorphous problem that I know that there are many companies, many frameworks out there that like promise that they provide an ultimate solution for, let's say, feature engineering and feature stores. And we kind of never could quite crack that code in a general manner. I mean, of course, like we could have ideas how to solve it for specific use cases, but in general, like what like you get today if you use Metaflow is that, well, I mean, again, like we help you with the basic foundational layer, and then like you can surely use different kind of let's say feature engineering, feature store approaches on top of Metaflow. But as of today, for instance, Metaflow doesn't come with any feature store built in. And I mean, if you ask me, I couldn't say like how we would go about like building or integrating one like really built in. to Metaflow. I mean, just because of the complexity of the real world and the entropy and like the number of different approaches that people want to take.
Yeah, can confirm from my own company, it is not trivial to implement one. We have one that's in public preview right now, and it is rather complex and required an entire, creation of a new technology, Delta Lake, in order to support the feature store functionality integrating with MLflow. Yeah, I think it resonates a lot also what you were saying there about we're leaving this open to use components that have already been built, because that whole reinventing the wheel, I think that's appealing to a lot of company cultures in engineering sometimes. We're like, well, the NIH syndrome, it wasn't invented here. It's not good. Somebody else built it. We need something specific. What wisdom would you give to particularly data scientists and ML engineers to prevent them from going down that path and saying, hey, if there's pre-existing art, you might want to potentially just use that?
Well, a simple answer is that choose a company that doesn't reward you, and doesn't include in your promotion package that how many new systems you reinvented. Unfortunately, it is a direct result of many companies working exactly that way, that if you're a senior engineer and let's say you want to get promoted to a staff engineer, you have to build some amazingly complex system. So you are directly incentivized to build a new database or build a new file system or build a new feature store. And I think that is totally rational. And honestly, if you are working at such a company, I think you have pretty much no choice except to implement the new feature store. So, I totally empathize with you. Now, luckily, Netflix isn't such a company, and I think many other companies actually can be quite rational as well. And then my point of view in general is that look, all this stuff is so very complex, and there are so many challenging problems that you want to really think carefully where you want to spend your resources. And I think that engineers constantly, of course, underestimate the complexity of everything in the real world. And then there's the temptation, especially, let's say, the feature store is a classical example, but it kind of feels that, okay, wait a minute. So, I'm just looking at things like whatever Amazon is providing, maybe whatever Databricks, Tecton, all these companies are providing. Look, it's a key value store. I know key value stores. And how hard can it be? We have some functions that input something in a key value store, and that's pretty much it. And maybe you can check the checkbox after that and say that we have a feature store. But then when you really start thinking about it and trying to run something in production, trying to support a new features being defined, both batch and real time, the complexity, it's just it spirals out of control. And our feeling was that since we knew that with something like Metaflow, we wanted to address so many different pain points, we absolutely couldn't afford really trying to reinvent any of these layers. Another good example is just a basic data warehousing that, oh my gosh, it'd be absolutely a fool's errand to try to reinvent anything there much. Compute layer, the same thing that we are relying on things like AWS Batch and Kubernetes and so forth. Of course, we should use whatever is available. And even actually surprisingly to many people, when it comes to this question of orchestration and how to execute these DAGs, although Metaflow comes with the built-in scheduler, then for production use, we will actually export to whatever production scheduler you want to be using. And the reason for that is that even although it's actually a fun, almost like an interview question that, okay, how do you walk through a DAG? Simple enough. It's a simple algorithm, but then try to do the same so that you have 100,000 workflows running in parallel. Each one of them may have 10,000 jobs. It needs to be highly available. It needs to be multi-master. It needs to be potentially multi-data center. It needs to be so that it monitors everything. It needs to connect to the systems downstream, upstream. So, it is getting so complex that I'm actually still sad that there aren't better solutions out there today, because it's such a hard problem that there are a few companies who have kind of solved it internally, but when it comes to open source, nothing is perfect yet. So.
Correct. Just maintaining state management across complex production development deployments. Yeah, it's a very challenging problem. And I think it's something that I don't think a lot of people that are getting into ML, those companies that are sort of nascent and trying to figure stuff out, and they're prototyping stuff, they don't really struggle with it because they don't know that they need to be struggling with it yet about, hey, what does production deployment actually look like? But established companies that they've gone past that first 3 sort of human in the loop manual deployment pain process. For all of those listeners out there, definitely give Metaflow a very good hard look and definitely read this book, because this is not like simple to manage yourself. And when you're having to do this manually, every single model that's out there, every single project that you're pushing to production, as that integer increases, that counter becomes larger. That's one more person's time that now has to be consumed with checking to make sure that everything's talking to one another. Yeah, I have one question about the book in particular. What's your favorite thing about what you've written, about the things that you're teaching, that you enjoyed writing the most and you think people are going to get the most out of?
Yeah, well, it's a good question. There are definitely many different parts. I would say that like one common theme, a common thread throughout the book is this question of usability and human centricity. And this like a notion that, well, at the end of the day, this is not about building an AI that solves like all the world's problems and like kind of somehow automatically makes your business more profitable. But I mean, it is that, okay, it is the question, how do we actually give tools to people, and especially give tools to people who don't want to spend all their days like thinking about these low-level questions. So that's a fascinating question always, because it's so much harder in a way than like any engineering problems. Now, like very specifically, there are like some topics I mean, there are actually like a couple of chapters about scalability and performance, and I really enjoyed like kind of thinking, because I mean, especially like in the context of engineering, there are oftentimes so many heated discussions even about like, oh, is it scalable enough and is it performant enough? And especially, let's say, I mean, like in the context of data science and Python, there's this notion that, well, I mean, it's Python, we can't use it in production, it's not fast enough. And then the kind of a thing that kind of like a bit like rubs me like occasionally is that, well, I mean, we kind of just like a name drop these terms like scalability and performance, and like, okay, so well, I mean, first, I mean, scalability and performance are different concepts. They are not the same thing. You can have perfectly scalable systems that are not performant at all. Mm-hmm. You can have perfectly performant systems that are not scalable at all. So first, I mean, like it's useful to distinguish between the two dimensions. And then that like you can actually keep walking these dimensions. You can actually start something that like was not scalable at all. I mean, it's totally valid. And actually this is something that oftentimes happens in the context of data science, that you should start by doing the math and kind of like seeing that, okay, so what do I actually need? And then like thinking your scalability requirements with that. I mean, my favorite example is that, okay, look, Netflix today has about, let's see, what's the latest number, like 210 million members. And okay, so you might think that 210 million members is quite a lot. So okay, it kind of like your first instinct is that, okay, it's a big number, we need scalability. Well, now the kind of an interesting question is that imagine having a data frame like that has 200 million rows. So it takes some amount of memory, and like definitely the instinct might be that like you need to distribute it. Well, interestingly enough, like when you do the math, and actually like even if you go back like 10 years time, and of course I think 10 years ago Netflix had maybe 70 million members, and you had a data frame with 70 million rows. At this time, let's say AWS, the largest instances that you could get 10 years ago, I think like had about like 120 gigabytes of RAM available. But I mean, still, I mean, you could store like, well, let's see, I mean, you could store about like kind of some kilobytes of data. So let's say, I mean, we are talking about thousands of binary features for each member, and you could keep the whole data frame or like a whole matrix in memory at that point in time. Now, the interesting thing that happened is that like as the number of Netflix members grew from 70 million to 210 million, so grew the sizes of these instances. And actually, I did the math, and like for the past 10 years, every single year, you have been able to keep this data frame in memory just by like piggybacking on like whatever is the largest instance available on AWS. Today, the largest instances have 768 gigabytes. I mean, just talking about the basic instances of RAM available. So you can actually still keep it in memory. And this is, I mean, just to give you an example that like when you think about performance and scalability, and there's this like a notion that, well, you kind of absolutely like must do it differently. Well, I mean, occasionally like, well, I mean, the computers like grow in size as well. And like, it might be just like a convenient to keep it as a data frame, depending how you encode the data. I mean, it might be possible that actually some simple approach might work. Now, I mean, that might not be the most realistic approach, the most realistic example in a sense that maybe it makes sense to shard the data and do it over multiple boxes. But another like a classical example is that, let's say your data set doesn't grow. I mean, let's say you are handling all the all the countries in the world or all the zip codes in the US, well, I mean, the number of zip codes, I mean, doesn't increase. I mean, like if you can handle the zip codes on a single machine or whatever processing you need to do, I mean, that's not going to change. I mean, it doesn't need to scale. So I guess the kind of a lesson learned here, and like going back to the question that why did I enjoy writing about it, is that because there's so many trade-offs involved in like making things more scalable and more performant. And like oftentimes, like really, I mean, this is the oldest thing ever in computer science, that you shouldn't optimize prematurely. And still oftentimes I see that, especially when people obsess about quote unquote production machine learning, that there is the temptation to even like optimize too early. And the biggest price that you end up paying by doing that is that then it makes iterations harder, and it makes harder to onboard new people. I mean, let's say you hire this amazing, like a PhD who has a PhD in math or like maybe in astrophysics, and they would be perfectly capable of building an amazing new model. But I mean, now they look at your highly optimized C++ code and they can't like really understand it a bit, or like kind of, it's very hard. I mean, let's say you have a distributed system and like they can't like reproduce these things locally. They don't know how to operate this distributed system. And now suddenly, I mean, this person is totally incapable of helping anything. So now you kind of have a technically performant or scalable model, but actually like it would be much better for the company to have a model that is not so performant, not so scalable, but I mean that more people are actually like able to improve and the end result would be better. So, and of course it's all about trade-offs. There isn't a single right answer, but again, I mean, like what I enjoyed writing in the kind of the 2 scalability chapters in the book is really kind of to focus on those trade-offs and like show that, look, you can take a gradual approach. I mean, start simple and like only increase complexity. And there are actually really totally amazing libraries available off the shelf today that you can use to kind of start simple and then like step by step make things more performant, more scalable as needed.
Hey folks, if you love this podcast and would like to support the show, or if you wish you could listen without the sponsorship messages, then you're in luck. We're setting up new premium podcast feeds where you can get all of the episodes released after Christmas 2020 without the ads. Signing up will help us pay for editing and production, and you can go sign up at devchat.tv/premium.
Man, you just gave me flashbacks with that example about scalability. A couple months ago, working with a customer who had done almost the exact same thing. They optimized the algorithm. They took matrix factorization. They rewrote it and tweaked it a little bit with some of the operations that were being done in order to customize for their business. And it was working brilliantly on their test data set that they were using, which was 5% of their users. And it was only about 20% of the items that they were trying to, like the products that they were recommending. And it was working great on an instance size, single node VM on AWS, actually. And then they spent 3 months working on that. And we're saying, okay, we're ready to start QA processes. We're going to push this to prod. Let's run it on the full data set. And of course, the VM ooms and crashes almost instantly. Right. So they start talking to us. We were already in there with the data engineering team. And like, hey, we can do a recommendation engine on Spark. You know, it's kind of a famous one that won the Netflix prize back in the day, right. ALS. And they're like, no, we can't use that because it doesn't solve this one problem. But it did, as long as you did post-processing heuristics on top of the output results, and it got a little clever with that. But you could still use alternating least squares, matrix factorization in a distributed system. But they actually tried for a month of trying to take their algorithm and distributing it. And they contacted us and saying, hey, we'd like to engage in professional services for you to take our algorithm and write a distributed version of it. And we're like, yeah, that's going to take 9 months probably, and a lot of research about how this equation works. So yeah, the early optimization, I think that's a great point, and it's a common theme in a lot of companies doing ML. When you get the clever people straight out of research groups that want to make a name for themselves, that have written papers, that want to now do it for real in the real world, sometimes you don't want to do that. It's great discussion.
I do have
go for it.
A quick question on maybe that one's for both of Vide and Ben, looking at kind of a meta framework for people just starting out in ML. How high of a priority should it be to start integrating this kind of framework in their workflow, just for Kaggle competitions or just day-to-day, smaller projects. It's probably beneficial at some point to be able to integrate into a framework like that. But how much of an early look should people be taking at how much of a benefit do they have from looking at that early in the learning process? Because that could pay dividends later on bigger projects. Or is it a good practice to just start out and say, okay, I'm going to run all my projects through this. I'll get comfortable and I can scale up and out eventually when things get bigger.
Yeah. Well, I mean, first, I guess the answer is that you don't have to. And I think it's very important that, let's say you are very early, in your career, and there are so many things you want to learn, and only so much time. So totally fine that you can focus on, let's say, if you want to focus on initially just learning basic data science, machine learning, modeling techniques. just open a notebook and follow tutorials that you can find, and no need to worry about anything else maybe in the beginning. Now, I would say that it's kind of a comparable to the question that, okay, so let's say you are a software engineer or you are learning software engineering. So at which point should you start using Git? Now, you can certainly hack a lot, and you can do all kinds of things without using any version control. And if you are a disciplined or well-organized person, you can actually kind of do everything, get really far without using Git. Now, if you join any company and you want to do it for a living, I don't think that you can much get the job as a software engineer if you don't know anything about version control and you refuse to use any version control. So in that sense, even if you think that you don't need it, maybe in the employment point of view, it might be useful. And then of course, it kind of maybe teaches certain kind of habits, and habits that are actually productive and useful, although you may not see the benefits at first. And of course, to what Ben was mentioning earlier as well, that of course, different companies have different need, and they're not everybody is of course Netflix, not everybody is Google, and there is certainly a kind of a graduation path. That's kind of the way I see it. You can start simple. Totally start with the notebook first, then start let's say, instead of just doing a notebook, what's fun is that you can just write this simple Python file. Maybe you organize your project as a DAG, as a workflow. Then you can execute it as a workflow. Then it's actually pretty fun. Even personally, that you can scale out to the cloud so easily. Actually, I personally find that it's much more rewarding even to do personal projects when you have a little bit more horsepower available. And so that's fun. And definitely there are things that you don't have to worry about for a long time. And even small companies, definitely the idea, and what I'm also trying to advocate in the book is that the idea is not that there's only one single way of doing machine learning or data science infrastructure, and everybody must do it the same way, and everybody must be like Netflix or something like that. No way at all. So you can definitely focus on the problems that are most pressing for you. There are some basics that you probably should be thinking, just for the kind of a hygiene point of view. And then the idea is that hopefully the framework, the approach grows as your needs grow. So I think that's a pretty healthy way of approaching it.
Yeah, and to follow on what Ville said, one thing that I do when I teach people who are trying to get into data science, and I do a lot of this mentoring internally at Databricks and in the community at large, is to prep people for using frameworks like Metaflow or any of the other ones that might be more applicable to a company that they're going to work at, is get really familiar with pipeline orchestration within ML frameworks. So if you use an scikit-learn, or you're using Spark, doing stuff in PySpark, any of those libraries, they all have the concept of pipelines. Those pipelines, when you're running the code, you might not realize what it is, but it's a DAG. It's a directed acyclic graph of operations that you're performing in sequence, and you can wrap that up as a single artifact to store somewhere. And that preps you for exactly what you had just said, which is, hey, when we go to production for real and we're building, say we're doing it in Python, we're building an egg or a wheel file that we're going to deploy. And this is a proper repository with good code architecture and abstraction in there. And we're writing classes, and everything is sort of production hardened. Everything is unit tested, integration tests. When you're getting ready to go to that, understanding and having familiarity with the pipeline concept, it's not a new thing that you have to learn. It's oh, this is just like sklearn pipelines, or it's just like Spark ML pipelines, but it's just a different abstraction layer. So I think that really helps. Now, the demos and examples that you see online are all imperative, almost exclusively, because that's a better teaching tool for people getting used to it. But that is not how production ML is written.
Right.
So I wanted to jump in on a couple of things. One is you've answered most of the questions, I think, as far as like infrastructure and thinking about infrastructure and kind of planning for it. With Metaflow, one thing that I'm wondering about is just like, how do I get started? Like, what do I have to know in order to start setting it up? It sounds like it takes a lot of the pain away as far as figuring out what the next right tool is in a lot of cases, right? And just kind of gives me the workflow and the, okay, you're probably going to need a piece here. Here's one that we recommend kind of thing. But how do I get started?
Yeah. Well, I mean, by far, I mean, the easiest way to get started is to, like, you just take your laptop, you write pip install Metaflow, then you can next like write Metaflow tutorials, and there's a set of tutorials that like walk you through the basic concepts, like what Ben mentioned about workflows. I mean, just kind of these like ways of thinking about things, and like also how you use notebooks with Metaflow, stuff like that. Now, the interesting thing is that most of the power of the framework comes from the fact that like you are able to use the cloud so easily to scale things out and like even deploy to kind of a production. And then like if you're curious, I mean, like you can definitely, there's a CloudFormation template. You go to the AWS UI, you just like put the template there and click a button and it deploys everything for you, and then you can actually start really like it's amazing. And this is something that like should be emphasized, that like although like we have been talking, and maybe kind of the listeners might get the impression that, yeah, I mean, there are like so many different things, it's kind of a complex business, but the fact is that it's amazing to be able to leverage the clouds, and they really like, it kind of feels that you are really definitely like standing on the shoulders of something that's quite giant. So if you, I mean, like I've been doing this for a long time, and like if I like remember like what it was to do anything like this, like even like back in like 2007, 2010, before let's say AWS was really available in the current form, it would have been absolutely impossible like for even mid-sized companies to do anything like what we are talking about here today. And even Netflix, I mean, they have spent huge amount of resources over time, like working like early on with AWS before AWS had all these abstractions, let's say, and of course the same applies to other clouds as well. So in that sense, it's mind-boggling that how much even a single individual can do today by leveraging these almost like a public utilities that are available, and also how surprisingly cost-effective it can be. So we are really talking about like really serious scale, like a Netflix scale, Google scale infrastructure, and like not only scale, but also like the high availability. I mean, the fact that, let's say, Metaflow integrates with something like Amazon Step Functions, which is a kind of a workflow service provided by AWS. And you can like throw any number of workflows there, and they just keep it running. And there's some, I mean, I'm sure that there's some Amazon engineer somewhere like with the pager, like kind of waking up at night if the system goes down, but it's not you. Yeah. And that's the key part. So I mean, you can just click a button, and like you don't even have to too much worry that something is happening. And there's someone else who makes sure that if there's a data center burning, they will like automatically fail over to the next availability zone and so forth. And that is honestly a small miracle. So thank you, AWS, for that. Of course, I mean, all this applies to Google Compute and Azure as well. So in that sense, yes, I mean, like you can start easily locally, pip install Metaflow also, but I mean, like, I want to emphasize like how easy it is also to take the next step and like go to the cloud and actually like start really benefiting from something that's really, really powerful.
Yeah, there's thorough tutorials on, like, if you go to docs.metaflow.org, it will walk you through with videos and step-by-step guides of how to get started on this, but also not just the hello world example. It'll run through like, hey, what does it look like developing on this? So there's guides there. It will walk you through everything. It's pretty slick. Good job.
Yeah, thank you.
And buy his book, and you'll find out more about how all of that is built.
Yeah. And then, by the way, I mean, like it's of course like nowhere near perfect. And I think like thank you, Ben, like for doing also like so much work in educating people, like helping new people to enter the field and teaching these concepts. I think of course that's the kind of a big underlying theme here, is that, look, if we assume that almost every single company, at least who does anything digitally, I mean, like, will maybe not want to develop custom ML applications, but will at least leverage some ML and data science applications. We need so many people doing this stuff over the next 10 years time. I mean, I'm really excited about like seeing all the kind of different people from different backgrounds innovating, like coming up with different ideas. And I think it's sad if it's really the tooling and the systems that are the bottleneck for human creativity, and then the fact that like our companies could become so much more efficient, like if only they could like deploy these things. And again, I mean, the thing, I think the big macro trend that's happening, that we are not only talking about kind of the crown jewel, like really visible applications like Netflix recommendations or like whatever, Google search or so forth. But I mean, like the tiniest little things. So for instance, at Netflix, somebody built a predictive progress bar. So they had this thing, they had the web application, and that web application, like somebody uploaded something and it took a while to process whatever they had uploaded. And then like there was a simple progress bar that like just basically was wrong, like almost all the time. Then they had a simple linear regression model that actually, like given what they had uploaded, the user, I mean, just take a couple of features and like you can actually have a really good prediction that how long it's going to take. And then you adjust the progress bar accordingly. And now suddenly like you have actually an ML powered progress bar that like actually improves the quality of life of people who are using this application, because they get accurate estimates that, okay, can they go for a lunch, or can they take a bio break, or like kind of is it going to happen immediately? And it's small things like that everywhere, and that's going to happen over like the next 10-15 years. But it requires that like we need more people doing this stuff, like we need better tooling, and of course like deploying these things in production. I mean, it needs to be manageable, because oftentimes it's a complexity that like kills everything. So I mean, that's why, I mean, it's I think I'm definitely on the mission of like trying to kind of get more people doing this stuff, and like at lowering the threshold. And yes, I mean, hopefully the book will help with that. Hopefully the tutorials will improve over time, and of course, like working on the framework as well.
All right. Well, I think you've answered all of my questions. I like the approach in the sense that, and this is something that I've run across in a lot of other projects that I've worked on, is that the infrastructure a lot of times is the stuff that you have to do the stuff that you want to do.
Right.
And so by understanding how it goes together and then having a framework like Metaflow, I can pretty easily go from this is the stuff I want to do, so I'm going to do the stuff I have to do, to, okay, a lot of this stuff, I've kind of got the big picture and the pieces that go into it. And so I don't have to spend as much time doing that, and I can get to the stuff that actually matters.
Right. Yeah. I mean, that's definitely the pretext. That I don't think that like any of these frameworks, the intention is that they will do your job for you. And I think that that's also like when engineers think about build versus buy, and going back to the question we discussed earlier, that, okay, so many companies or like engineers have tended to kind of trying to reinvent the wheel. Well, really the idea is that like there will be many, many wheels to be invented. So you don't have to reinvent anything, because focus on the invention. And also don't handicap yourself by not taking something that's already available. I mean, like, of course, you want to get the biggest head start that you can possibly get, and like implement the basic infrastructure, and then like focus on helping your company, or like kind of doing whatever excites you on top of this baseline. And at the end of the day, I mean, we are talking about the baseline. This is not the end goal. I mean, it's not that when you deploy Metaflow, when you deploy any of these frameworks, that suddenly, I mean, your work is done. I mean, view it more as a starting point. And then that's actually where the fun begins. So
yeah, it's automating away all the stuff that a data scientist, they might be excited to do the first time, but they never want to do again after they learn how to do it. These frameworks, these tooling for infrastructure and for helping you actually run your stuff, they're saving you a bunch of time so that you can actually solve problems for a company, rather than solve the technical challenges with deploying things. So I personally think they're invaluable. And if you're trying to just roll your own and build it from scratch, you're taking up valuable time that you're not figuring stuff out and coming up with creative solutions to the problems that your business is having. I mean, most of us join companies as data scientists to solve problems, not to learn how to build infrastructure.
Yeah. Yep. And by the way, I mean, like if you take a look at my book, the idea there is that I'm definitely like very engineering minded, always has been, like all hacker engineer. And I, of course, also want to know how things like work under the hood. So it's also not like trying to underestimate your capabilities as an engineer, let's say, or like as an engineering minded data scientist. So by all means, actually, it is useful that like you have like some good level of understanding how these systems work. So I mean, definitely, I would encourage you to kind of a peek under the hood. and like then get the confidence that like even when something fails, you have an idea what happens. But I mean, then like, yeah, I mean, like maybe you don't have to still like implement everything from scratch. So, and that's with the book as well, that I didn't only want to tell that, okay, here's this API, call this API, and out comes a model. But I mean, so that, okay, here are the building blocks, here are these systems work. Okay, I mean, like now, I mean, a good example is something like this, like a large scale compute. Okay, so it's a good idea to know roughly like how this, let's say, container management systems work and like what are the moving parts involved. But I mean, then like once you have an idea, then you can use whatever is available off the shelf. You don't have to do it by yourself. Or something like a Spark. I mean, like, yeah, I mean, having a basic idea how Spark works, definitely a good idea. I mean, and you can even like peek under the hood if you dare. But I mean, then of course, I mean, like maybe you don't have to spend too much time on like kind of trying to kind of re-implement the whole thing from scratch.
But understanding how your infrastructure framework works allows you to extend it, which that's really super critical. If you're like, well, the tool doesn't do what I really need it to do, but having that guide to say, oh, that's how Ville implemented that in this tooling. I'm going to go check out the source code. I'm going to see how he built this other similar thing. I'm going to try to replicate that to solve my problem. And that's what I think is so valuable about not only the docs that are part of this, but having that book as a guide as well, as saying, okay, I now know this enough to not create dangerous, extensions of it, but actually successful extensions that'll actually work in production.
Yep.
Awesome. You've answered all of my curiosities so far. I mean, I could talk to you for like another 8 hours straight.
Yeah. Likewise,
but yeah, this is awesome.
Yeah. Thanks a lot. I mean, this has been great. And yeah. Also, by the way, any of you listeners, I mean, are interested in learning more, like if you have any questions that didn't get answered, so you can definitely find me online. We have a Slack channel. You can find me on LinkedIn, whatever, like Twitter is even. So, I mean, whatever works for you. So, I mean, don't hesitate to ping me and ask questions and like just get in touch.
Awesome. How do people find you online?
Good question. Well, I mean, probably if you just Google my name, I mean, you will find LinkedIn. You can just like ping me there, or like you can probably find Twitter as well. It's my VTUULOS on Twitter, so that works as well. Ville@outerbounds.co is the email. So yeah.
If you just type Ville and then if you type ME, he will be like the first thing that fills the top 20 pages of Google results.
There's actually like there's another rock star like from Finland, so that's also like Ville. So and he, strangely enough, he has the same second name as well. So you might confuse me with the rock star, but if you look at the photos, I think the difference is obvious.
As long as Meta's in the query, it'll show up.
Yeah.
Nice. All right. Well, let's go ahead and do some picks.
Hey, folks, I don't know if you've noticed, but I've been working a lot on figuring out how to help people become the most valuable developers on their teams, or becoming the top 5% of developers in the field. If you're looking to level up, figure out how to contribute more, get the career you want, get the career that you want that will support the lifestyle you want, then you should check out the Most Valuable Dev Summit. I've invited some of my friends across the community, people that you've heard of, people that have worked on systems that you use on a daily basis, people who have invented new ways of doing things over the years in programming, and I've asked them one question, and that question is, how do you become a top 5% developer? How do you become 1 in 20 of the best developers out there? And so we're going to go ahead and have that conversation with them in interviews on the Most Valuable Dev Summit. And you can find that at summit.mostvaluable.dev.
Francois, do you want to start us off with picks?
Sure. Another, once again, it's just a little tool. I don't do flowcharts that often, although sometimes, once in a while, I'll need to draw a flowchart for a client, clouds pointing to squares and all that good stuff. And I don't know, I'm just generally annoyed that it never puts the arrow in the right spot, or I have two arrows pointing to the same thing and then they overlap and it's unreadable. And I was just using a Lucid chart. And so far it's been the one that works as closely as it does what I want it to do, as far as, having a nice clean diagrams and arrows bending and going the way I want. So just a bit of a tip of a hat to Lucid Chart. They have it's an online service, so you can collaborate and all that stuff. It's kind of like Google Draw in some ways, but it just seems to work. And that's what I need, because I don't do that many charts, and I just want them to be done with. So that's my pick for the week.
Awesome.
Your pick is is how I spend 10% of my life in that program. All of our architecture diagrams at Databricks that we share with clients are all done in Lucidchart. Yeah, it's an awesome tool. If you need to build some really complex stuff, it makes it pretty trivial to do it. Yeah, that's a good pick.
Awesome. I kind of stumbled on it, like being mad at a certain project. Like, I need a new tool for this. I'm like, oh, this actually works finally. So glad to hear it's battle tested.
Oh, definitely. My pick, it's sort of self-serving. My apologies, but it's the feature store that just got released from Databricks. And I don't normally talk about my company's tech on stuff that much, but the integration that was built between Delta and MLflow and allowing you to serialize all of the operations required to create universal access across an entire company to pre-calculated sort of static features that can be used in multiple models. Definitely check it out if you're curious, if you're struggling with like, hey, I only want to define my features one time and we have 80 different potential, model usages for it throughout the organization. Yeah, it's pretty cool. And I've been having to dive pretty deep into it because I'm finishing up the last chapter of the book. And it's going to be pretty heavily featured in that. That's my pick.
Awesome. By the way, Lucidchart is a local company. Their headquarters is in Utah. I'm going to pick a fictional book, and then I'm also going to pick something that's not really... you can go to the hardware store and get this stuff, I guess. So the first pick, I've been listening to this book on Audible. It's rather long, and I'm really, really enjoying it. And it's made me think about a lot of different things. And I think it's fairly applicable to some of the stuff we're going through now. It's Atlas Shrugged by Ayn Rand. I picked it up. I'd heard a bunch of people talk about it over the years and just never read it. I was like, all right, let's see what this is about. And yeah, I'm really enjoying it. So I'm going to pick Atlas Shrugged. And then the other pick I have, so I went and helped one of my neighbors move. Her husband had passed away. She was moving up to be closer to her kids. And anyway, she had some desks that she was getting rid of. And so she's like, just put them on the street and put a free sign on them. And I'm like, no, guys, just put them in my truck. I'll drive them around the block to my house. I have a bunch of monitor arms though, and it really didn't have a lip that I could connect them to so that it would hold everything up. So I went down to the Home Depot. I got some 8-inch C-clamps and 2x6. And I cut the 2x6 in half because there were 2 desks. And just clamped the 2x6 to the desk. And now I have an 1.5 inches thick, probably 3 inches worth, 3 or 4 inches worth of wood that I can clamp all my monitor arms to. And it's working really well. And so I just kind of jerry-rigged myself a lip that I could put all of my monitor arms and other things that I clip to the desk on it. And so, yeah, if you're looking for something like that, the only trick I really had to play was, so the desk is open on both sides. So I just had to get the C-clamps that were deep enough to go all the way down to underneath the open side of the desk on the other side, because none of the monitor arms, I mean, they clear like 2, maybe 3 inches, right, to clip onto something, depending on what I had. So anyway, good stuff there. And then I guess the last pick that I have, and this was sort of related to what we talked about today, but on Adventures in DevOps, we did an episode about bioinformatics in DevOps. And our guest, I think her name was Jillian, I can't remember. Anyway, she kind of has this methodology for setting up data science and AI flow for bioinformatics labs so that they can feed all their data in and stuff like that, right? And then she just adapts depending on what their data flow is and what algorithms they're using, right, to help them to get it Dockerized and deployed and all that stuff. And so that was really interesting. So I'll put a link to that in the show notes as well. Ville, do you have some picks for us?
Good question. Let's see. I mean, I actually recently moved to San Francisco. Like, I have this new house, I guess. Well, I mean, like what I learned, at least like being in this part of the city, is that like having a good jacket is a good idea. Like, it's so foggy in July. So, and let's see, like what else is a good one. Yeah, no, I mean, like there are like so many tools. Actually, like let me mention one. So what's this service? There's the it's called like a Open Weather API or something that I actually like recently used to get weather data. I and like actually just to develop some tutorials for Metaflow as well. So it's like really nice, slick service that I mean, just like kind of, I mean, it's amazing that like how I was expecting that like getting like real-time weather data would be like something really simple. But I mean, apparently like there are many, many different providers and like that one seemed to work really well. So it's kind of a fun experience.
How granular does the localization go?
Good question. I mean, it takes latitude and longitude. So I don't know. I mean, like,
Okay.
I mean, what's funny thing is that like I actually like tried to see if I can forecast weather for San Francisco. It seems to be impossible. I picked Las Vegas instead. I mean, much easier. There's just like I guess like a too windy, too unpredictable here.
Right.
Nice. All right. Well, we're going to go ahead and wrap up here. Thanks for coming. This was really, really interesting.
Thanks a lot. Thanks for having me.
All right, folks. We'll till next time, max out.
Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CACHEFLY.com to learn more.